to the first day of our week-long Astronomy Days celebration. I'm Carrie. I'm an educator here at the museum, and I am so excited to be here with you today. So we are really excited about our presentation this afternoon. But first, we have an icebreaker question for you. So let me know in the chat, who is your favorite astronomer? So just put that in the chat. And while you're doing that, I'm going to go through a quick Zoom tutorial just to make sure that we all have the best viewing possible. All right. So this program is closed captioned. We have live captions. And so if you would like to use those captions, down at the bottom, click closed captions, show subtitle, and then the captions are going to show up for you. They're going to look just like this. Now we want to go side-by-side mode. So if you go up to viewing and click side-by-side, that's going to move the speaker off the slide so that they are not impeding your view at all. And you want to also make sure that you're in speaker view. Lastly, we want you to chat with us in the chat box. So ask your questions, comments, but just keep it on topic and make sure you're kind and respectful to everyone. Okay, and with that, I'm going to introduce our speaker. So Ian Hewitt is an research adjunct at the museum in the Astronomy and Astrophysics Research Lab. But also, Ian is one of the planners of Astronomy Days. When I first started 14 years ago, I worked with Ian on Astronomy Days. So he has been just an integral part of this event for many, many years. So thank you, Ian, for everything you've done for Astronomy Days, and take it away.
Well, thank you very much, Carrie. I really appreciate it. Certainly Astronomy Days is a great event, and I'm excited to be here, virtually or electronically excited to be here, I guess. Welcome, everybody. So I guess I should say, depending on when you're watching this video or where you're watching this from, good morning, good afternoon, good evening. So that's the traditional thing for Zoom these days. So what I am here to talk about, again, as Carrie said, my name is Ian Hewitt, and I am a research adjunct in the Astronomy and Astrophysics Laboratory here at the North Carolina Museum of Natural Sciences. And I also teach at Coastal Carolina University. I've always, been astronomy, which is basically what I do, but I've always been very interested in history. Recently, fairly recently, in the last couple of years, I started looking at some of the history of women in astronomy. It's been a very interesting journey doing this, mainly because it's actually really, really difficult to find material on it. It's actually quite surprising. But there's actually been quite a bit of, women have had quite a bit of involvement in astronomy over the last 150 years. So I thought I'd highlight some of them, and I have my title of my talk, Escaping the Touch of History, which I saw somewhere, and I would credit it if I remember where I ran across that one at one point. But I thought that was really, really particular, really particularly accurate. So this is some should be famous women in astronomy. I'm going to focus on American women or people that practice astronomy in America. It's by no means complete. There's certainly actually women have had a large history in astronomy. It's very significant history in astronomy, but it's not complete. But I'm just focusing on some of them here. So this is just part of the story. It's really impossible to do this story real justice, especially in 30 or 45 minutes. It's surprising how much history there really is, but there's just too many stories for one talk. But I'm going to try. This, of course, is a picture at Harvard of the Harvard computers, which is what they basically called astronomy people that reduced data were called computers long before they had electronic computers. One of the interesting things you get in a lot of these pictures is, even though there are pictures of a lot of the Harvard computers, many of them are not captioned. And so actually, when we look at a lot of these pictures, some of these women, from other pictures, we do know who they are, but then some remain, we don't know which of the women they were, right? So it's pretty amazing. Even if you go to the Harvard archives, there is a whole bunch of things that just the information's just been lost in terms of you see pictures of women astronomers working, and their names aren't even captured on the pictures, and no one seems to know. So you'll see that sometimes I don't have pictures of some of the folks just because I can't find a verifiable picture. So as I said, what really surprises me most when I started looking into this was there's relatively little information to be found, even on the internet. And that's really surprising, because usually even if the quality of the information is not exactly awesome, you can find information on just about anything on the internet. And you can find some on the history of women in astronomy, but it's actually very, very surprising how small it really is. There's some at the Harvard archives. Again, it's kind of piecemeal. Most of what's out there on some of the websites that you find if you do some Googling is a result of the publishing of this book called The Glass Universe by Davis Sobel. And this is a picture of Davis Sobel as well on here. This is actually a really good book. She called it The Glass Universe because, of course, all the photographic plates that they used were on glass. The negatives were on glass. That's how it was done for a long time before they went to the cellulose. It's very, very hard to access primary sources in these cases. She actually had access to all the journals of all these women astronomers, and actually spent a lot of time going through the journals and put together the story and basically tried to kind of capture some of what was going on and some of how they felt about things. And that's actually really, really convenient, because as I started going through all this and read her book, and I've read some of the primary sources as well as some of the stuff on the internet, and it doesn't always agree, right? There's a lot of stuff that pops out on the internet that really isn't backed up by what's in the primary sources. So I'm going to kind of try to talk about, basically what I've discovered and that kind of thing. So kind of have to rewind. We're going back about 100 to 150 years ago in America. And, one thing about history is it's really interesting. And there's this interesting book by Otto Bettman called The Good Old Days, They Were Terrible. I mean, a lot of people tend to remember all the things in history about the past was always so much better, or it was so much simpler. In reality, when you start talking about 100, 150 years ago in America, it was not simple and it was not that much better. There was a huge national divide going between the industrial East and the agrarian Central South. The divisions were as strong as what we have today in the political divisions we have today. There was a lot of conservative versus liberal politics. And what's very important when you talk history and you start thinking about, when you use the word progressive or liberal, you kind of have to define what that means. And I've got quotes around it, because a liberal position back then was that women should have the right to vote. Because you have to remember, during a lot of this period, women did not have the right to vote in the U.S. The right to directly elect senators. The senators were not directly elected by the population. There were minimum wage laws, and also work standards laws. What I mean by work standards laws are like maybe children under 12 shouldn't be employed in mining. All of which was going on. These were all considered very, very liberal views. So it's a little bit different. This is also the era of the Dunning School, which is the Confederate lost cause, and the start of the Jim Crow era. There were a lot of tensions between immigrants and self-styled, quote unquote, real Americans. And of course, America was dealing with imperialism, right? So the Spanish-American War kind of made America, starting to have colonies. And there were lots of people for that, like Teddy Roosevelt, and lots of people like Mark Twain who were very opposed to that. And then there was, of course, the whole discussion about prohibition, which actually is something very interesting if you study, because it actually kind of wraps up all these other issues and gave a way to talk about a lot of these issues. And then prohibition was about so much more than alcohol. So just so you know, in terms of a little bit of the things that were going on, really one of the first famous American women astronomers was Maria Mitchell. and she was born in 1818. Her parents, especially her father, really encouraged her to learn and did a lot of astronomical observing with her. By the time she was 12, she did a lot of calculations, navigational calculations, and basically within a couple of years, she was trusted to do that by a lot of sailors and navigators, and so she actually was pretty well renowned for that. And she took a job as a librarian because it let her continue studying. So she had lots of extra time, and so she could actually study. It was a passion of hers. She liked to do a lot of observing. This is actually, if you go up in to her house, it's actually like a museum now. And she actually, during a party, she liked to go out observing, and she did. And she noticed a nice fuzzy spot, dragged her father out of the party in the middle of, having all the good time, and basically discovered a comet. So this was in 1847. So her father wrote to Harvard Observatory, but the mail was delayed by a storm. So it turns out there's an Italian astronomer who was a Jesuit priest. For many of you that don't know, that actually the Catholic Church has a very active astronomy program. He got credit for the discovery of the comet and got a gold medal from the King of Denmark. The Harvard Observatory director at the time actually agitated really hard for her to get credit. This is the first of several Harvard Observatory directors who are going to promote women in astronomy. And the king actually reversed his decision. She actually became the first woman elected to the American Academy of Arts and Sciences ever. And she was actually made a professor of astronomy at Vassar College in 1865. Now, the one bit of good news here is, in a way, she insisted on the same salary as male professors, which, by the way, was not normal. And she actually got it. So she's actually supposed to be a really interesting person because she would not settle. So she became one of the first professors. Probably one of the most famous one that probably almost no one has heard of is called Sarah Frances Whiting. And she was the first professor of physics at Wellesley College, about 1865, so right after the Civil War. She went to a lecture given at MIT by Edward Pickering. And Edward Pickering is going to be a very important part of our story for the Harvard computers. And he was always very supportive. And so he encouraged her to look at some of the latest spectrographic techniques. And why this is important is she started teaching an astronomy course in 1880. And a lot of the Harvard computers that had degrees all came out of her program. So Sarah Frances Whiting would produce some of the astronomers that did some of the major achievements that we're going to talk about. Of course, she didn't have a doctorate because that just wasn't done, right? Women did not get doctorates, but she actually finally got one conferred on her in 1905. So you kind of looked at that's like what, 40, 45, 50 years. So it's quite a long process. And unfortunately, you're going to see that quite a bit, right? So then we're going to talk about, I know it's a famous woman in astronomy, but there are some men who figure in this. So I'm going to talk about a couple of dudes and how they sort of figure in. One is Henry Draper. He's an American doctor and astronomer. His father was the first to photograph the moon ever in 1840. And he basically pioneered a lot of things in astrophotography. Remember, this was a time when an amateur with good funding could actually do as much or more than professionals could. And he actually basically pushed the photographic technology and the spectroscopy combined with photography into the professional realm. He was the person that really pushed it, and the professionals picked it up. So he was very big on astronomy. In fact, on his honeymoon, he actually took it to a city where he was going to pick up some stuff for a telescope. That's what he did for his honeymoon. And just a couple of pictures from him. Sorry, it looks like I had a little error on my slide there. This was a picture his father took of the moon. So we still have that. Again, 1840, not too bad. And these are a couple of pictures that he took. The one on the left is a little blurry because unfortunately it's deteriorated over time. But and you can see some also deterioration on the one on the right. But you can see that actually this is the Orion Nebula. It's actually pretty good considering this was, probably around the time of the Civil War. So the other thing he was working on and really kind of brought into the professional realm was spectroscopy. So what is that? Well, if you look at a spectrum of something, you could have, if you have just like a light bulb, or you can think of it as an LED bulb now, I guess, it produces a continuous spectrum. So this is the rainbow color, just like you get when you have a prism. But if you either have a hot gas or a cold gas, what you get is you get a different kind of spectrum. You either get solid lines or you get gaps, and these actually relate to each other. And when you look at these gaps or the solid lines, they're actually unique to the elements that are in the gas, and they're like a fingerprint or a barcode. They uniquely identify the type of element and really its configuration, in terms of whether it's ionized or whether it's missing electrons, has extra electrons, things like that. They'll all generate different patterns. And so it's one of the keys to understanding light that's coming from stars. Here's actually some of his spectral pictures from Henry Draper, compared with a spectra taken in a lab of certain elements. This is actually out of one of his books. So why this all matters is his wife, Mary Anna Palmer Draper, was a very wealthy socialite, and she's one of really plugged into the aristocratic class that was really sort of running the U.S. at the time. And she marries Henry Draper and works alongside him for 15 years and becomes an expert astronomical technician. She wasn't a theorist, but she was a very good technician. The thing about Anna Draper is she was hugely influential and had a long reach. She had connections all over the country, and not only had those connections, but she wrote a letter to the head of the Smithsonian who she had connections to, she would get an answer. She is actually going to help propel a lot of the women astronomers forward, right? Henry Draper has a very early death. He dies very early of pleurisy, which is like an inflammation of the lungs. And she wants his work to be carried on. So she not only created the Henry Draper Medal, and she'll help found the Mount Wilson Observatory outside Los Angeles. Like I said, she was very influential. But she's actually going to look to do an endowment of all the equipment and the images he had, the data that he had, and wanted the work to be published and also the work to be carried on. So she's going to be one of the driving forces behind all this. This brings in Edward Charles Pickering, who's the head of the Harvard College Observatory. And so Harvard is now today one of the leading centers of astronomy in the world. It was not so at this time when he was elected in 1877. It didn't even have a graduate program. But he was a very, very good scientist. He all believed in getting data first and then creating the theories. So he's real big on that. And he wanted to work on spectra. So, of course, when he got the endowment from Anna Draper, they were very excited not only to get the equipment, but to get all the plates and the data. Here you see a picture of the observatory around 1899. This is after they started doing all the work. You see this brick building is where they housed all the glass plates. They built it out of brick because they were afraid of fire. And so that was always something they were very concerned with. They didn't want to lose all these valuable plates. So Anna Draper gave all the equipment and a large endowment to Harvard to do the follow-on work. This is one of the Draper catalog. We still use HD designations for stars today. And one thing Pickering had always noticed, and this was true in a lot of observatories at the time, is that there were women assisting with some of the astronomical work. But they pretty much were all female relations of Harvard staff. And they would be like, daughters or wives or things like that. And again, it was more of an informal arrangement than it was a formal arrangement. So one of the first formal arrangements was actually one of these relations called Anna Winlock, and this is one of the people that I can't really find any verifiable pictures for. She was the daughter of an astronomer, but when her father died, her mother and her 4 siblings needed support. So at age 14, because she kind of had a talent for this, she went and convinced the Harvard Observatory to hire her as a computer. And they hired her not only because, they knew she was the daughter of an astronomer, but, let's face it, she was cheap. Astronomy was not very well funded then, really not very well funded for a long time. And she was much cheaper than the other options, so they hired her. She ended up working for 33 years at Harvard and helped produce a lot of extensive star catalogs. She was really the first computer at Harvard. So the first, one of the most interesting ones, or one of the more interesting ones, is Wilhelmina Patton Stevens Fleming. And this is interesting. She had no astronomy education background. She was born in Scotland. And she had no connection again to astronomy. Of course, in Scotland, she, as a young woman, she met a young man, and as things will happen, they fell in love, and as things will happen, they got married, and as things will happen, she became pregnant. And then she emigrates to the U.S. with a husband and child. I guess the husband really did have some kind of American dream, and I guess it didn't really involve having a family, and he disappears and is lost to history. Unfortunately, this is in the late 1870s, that's put her in a very difficult position because there were not a lot of opportunities for women in the 1870s. So she ends up going to work as a domestic, because either clerical work or being a domestic was, or maybe working as a school marm or a nurse were about the only things, and they were actually really particular about who was nurses. So she ended up going to work for a maid, but she ended up going for the Pickering family, Edward Pickering, the director of the Harvard Observatory. At the time, Pickering was not happy because he had hired an assistant, some young man who I guess had looked good on paper, but he kind of thought she was an idiot, or sorry, that he was an idiot. And it was really frustrating. And it was actually his wife, Lizzie Pickering, who recommended Fleming and said, look, this woman has a lot more talent, has a much better mind than someone who should be doing domestic work. You should hire her. And started bugging Pickering to hire her. So he actually hires her in 1879 as an administrator, makes her an official computer in 1881. And she's actually going to be named the head of all the Harvard computers by 1886. And she's going to be responsible for editing all the publications by the observatory. She will do a lot of things looking at these glass plates. Now, at this time, she'll just be looking at glass plates. None of the computers will be using the telescopes because it was not permitted for women to use any of the telescopes at this time. That will change in our story as we go on, but at this time, they aren't allowed to touch any of the telescopes. So they just have to deal with the plates coming back. She'll discover approximately 400 things: nebula, stars, nova. The Horsehead Nebula, a picture which I have here, she'll actually discover that. And she'll become quite well known. She'll actually give a talk about women in astronomy at the 1893 World's Fair in Chicago. In 1899, she'll be formally, and I have that like bolded and underscored because that's going to be part of our story too, she'll be formally named the curator of astronomical plates at Harvard. I think one of the reasons this happened is that at the time, Harvard was gathering a lot of astronomical plates and it was becoming a big deal, but it wasn't really very well-known big deal. And so I think the administration of Harvard said, oh, well, curator of plates, a woman, but it's plates. So I don't know why they have plates in the department, but it's okay. Because you'll find that that's not going to carry on. She's actually going to be the first American woman made an honorary Royal Astronomical Society member. And that was really something. You couldn't be a fellow at the time unless you were a British citizen. Although she was technically a British citizen, you also couldn't be part of the Royal Astronomical Society if you were a woman. So this is actually one of the first women they actually let into the Royal Astronomical Society. So she was the department she ran was the Harvard computers. This is a picture you often see of the Harvard computers. It's from the archives. Again, we don't know the names of all these women. This is not the conditions they worked under. This is actually a picture. You can see Charles Pickering standing in the back. You can actually see Anna Draper standing there as well. This is actually on one of her visits, and they actually tried to gather everybody together so they could take a picture. Not that they had a terrific work environment, but it wasn't this crowded where they were on top of each other. So that's actually commonly It's a common misconception. But Pickering and the subsequent directors, the two, he and another one we're going to talk about, they would hire many of these computers. It was commonly referred to as Pickering's harem. He had to take, a lot of people think, well, Harvard's a liberal institution, or maybe scientists at the time were very liberal. Actually, they took a lot of flack for doing this, right? And so he constantly got Pickering's harem, and he was subject to tons of jokes. The women were constantly criticized for being out of their place. It was something that was he got a ton, both Pickering and the women got a ton of criticism during their tenure, even though they were doing really terrific work. This is actually a little more like what it would be where they were working. So this picture here, again, most of these pictures are just numbered, and they're not very well described in terms of who they are. This is actually a little bit later, but this gives you an idea of the working conditions.
So Ian, we have a question in the chat,
sure.
And I think that it's so someone is asking, why would they be criticized for doing this work? And I think maybe talking about a little bit, maybe for some of our younger audience members, it might be helpful to describe kind of what the world was like back then.
So that's a great question. So that's terrific. And, there was a lot of changes going. One of the reasons I mentioned the changes earlier, the lot going on in the U.S. And this is right around the time when people were talking about women getting the vote. That actually was a very long process. And there were a lot of changes, and many people reacted as they willed to changes, as that they pushed back against that. And many felt that, or I guess many men felt that women had a certain place, which was to be wives and mothers and be cooking, and that things had to be exactly that way. And so they didn't feel that it was, they didn't feel it was appropriate. And so they pushed back on it. There were a lot of people who felt that they should behave like women, or they used to call it female roles. So that was why they got a lot of pushback. They felt that this wasn't a womanly thing to do. There was also people who felt, so there were people who felt that women had a limited capacity to do activity and things, and the more that they focused on doing like scientific work, the less they were good at other things. I know that sounds completely ridiculous, but that actually was one of the medical theories at the time that many people bought into. So I hope that answers the question, right? Of course, now we know none of that's true, by the way, to be clear, but certainly that was what was commonly believed by many people at the time. And many people who would push back at the time thought they were actually doing a favor to them because they were diminishing their other skills in life, right? Certainly untrue. These computers made really significant contributions, but it was not a way to get rich. The pay would be something like 24 to 50 cents an hour. It's really hard to compare that with today, but basically it was equivalent to an unskilled worker's pay, like somebody who was digging a ditch. Or teachers' pay. The reason there were a lot of female teachers at a lot of schools that were not colleges was because the pay was so abysmal, right? And it was much less than traditional clerical pay. So these computers were actually doing it for the interest of astronomy, not to get rich. And this is going to be true all the way through, pretty much all the way through. The salaries are going to be a constant point of frustration for all these computers. In fact, one of the biggest points of frustration. So one thing Pickering and Fleming worked together on, and they did the stellar classification. And so all the data was organized and processed by Fleming, and she was assisted by another one of the computers called Antonio Maury, who is the niece of Henry Draper. And when they looked at all these spectral signatures that we talked about, the hydrogen lines, and they're marked here, alpha, beta, and gamma, delta, and so on. They looked at the strengths of that, and they actually classified all these stars into bins or buckets. And they classified them from A to M, A, B, C, D. Kind of makes sense, right? And they did this, and they pushed this out, and this was a classification system that was used for just a little while. It was only used for a little while because of Annie Jump Cannon. And it's just interesting. She's very interesting. She was actually, there was an organization, and the name of the organization is slipping my head right now, that named her by about 1918, 1920, named her one of the 13 most influential women in America. Her mother taught her constellations and encouraged her to pursue her interest, and really, kind of encouraged her. She studied astronomy under Sarah Frances Whiting that we talked about. She lost her hearing and her mother. So hearing loss was not that uncommon. Scarlet fever was quite common back then. One of the side effects of getting scarlet fever was you lost your hearing. She was hired as a junior physics teacher at Wellesley, and she enrolled as a special student at Radcliffe. It really wasn't called Radcliffe. It was called the Collegiate Society for Women at the time, because they said you couldn't call it a college because you have women there, and so they aren't really getting degrees. So, but they were essentially doing degree work and getting full educations, although it wasn't actually very recognized. Pickering definitely hired her as an assistant in 1896, right? And she will actually be quite famous because she actually reorganized this classification system. If you've ever taken any astronomy or anything like that, you recognize the spectral sequence we have today is like O, B, A, F, G, K, M. And you say, well, why isn't A, B, C, D? Well, because the original ABCDs weren't organized correctly. They weren't organized by temperature. The great insight that she had was to organize this by temperature. And so they kept the classifications because they already had a bunch of stars categorized in these buckets. And so she reorganized this into the Harvard classification system, which we still use today. And so this was actually a really, really big deal. She was actually the first woman in astronomy to receive some accolades and awards. She was the first female officer of the American Astronomical Society. She was the recipient of the Henry Draper Medal. Unfortunately, the next woman to get it won't be till like the late 1980s. She established a specific award for women in astronomy to promote this. In 1911, she became an honorary member of the Royal Astronomical Society, and that was a big deal because she wasn't a British citizen. She received in 1918, so again 20 years after she first started working on all this stuff, she received an honorary doctorate from the University of Delaware, where she was from. And she also was a really big deal because in 1921, she became the first woman ever to get an honorary doctorate from any European university. So the European universities did not grant degrees to women, doctorate degrees to women, which is why you'll see so many, as the Harvard computers go forward, you'll see so many people moving from other places because the US was a place you could actually potentially get a job where you couldn't get any of those jobs in Europe. But the glass ceiling's not really shattered. You may think, wow, that's it. It's like people are actually recognizing it, but they're not. And you may think Harvard was doing this because they're a liberal institution, right? So they're all liberal, right? No, this is not really the case. It's really an anomaly inside Harvard. In 1911, Wilhelmina Fleming dies. And of course, Annie Jump Cannon, who now, is pretty much world famous in astronomy, has been working on these plates. She's nominated by Pickering to be the curator of astronomical plates. And it makes sense. She's the most qualified person in the world. At this time, the Harvard president this time is George Lowell. He's actually the brother of Percival Lowell. And he objects very strongly. He says, let's not make a habit of this, meaning putting women in official roles. He indicates the first appointment was anomalous, which happened before he got there. And he basically totally refuses. He said Pickering can unofficially put her there, but she's not officially made. She's not listed in the Harvard staff directory. She's not recognized by the Harvard administration, any of that. It will eventually be made official, but it'll be a very, very long time coming. So you may think the glass ceiling was kind of pushed through, but not really. So, and this is going to be a common theme going through this, right? When it was made official, it wasn't until 1938. So you can see it took 27 years before it was made official. So, and of course, that's after George Lowell actually left as president of Harvard, right? He was actually, well, we're going to talk about some of the directors of the Harvard Observatory, kind of allies of the women in astronomy. You could say that George Lowell was in the camp that he was actually, you can't say he was not an ally. You can actually, he's actually an opponent of women making progress because he specifically tried to throw roadblocks in everybody's way. So in addition to Annie Jump Cannon, a name that probably everybody should know, but probably doesn't, is Henrietta Swan Leavitt. This is a picture of her. I don't know how old she is. It's funny. The pictures of her, all of them like these are all indicated, prior to 1921 when she died. And in some of them, she's got gray hair. Here she doesn't have gray hair. So I have no idea when this was taken. She was classically educated at Radcliffe. And she goes right from Radcliffe to becoming a Harvard computer, but leaves to travel around, comes back about 10 years later. And she gets assigned, again, becomes a computer again, and gets assigned to study variable stars in Magellanic Clouds. Now, the Magellanic Clouds are two nearby galaxies to our galaxy. She was also known as a fiend for variable stars, to be very passionate about variable stars. So what she was studying was something called Cepheid variables. So what are these? These variable stars change brightness regularly in a pattern. And different types have different patterns of changes. This is what the Cepheids look like. And you can see they sort of drop off in brightness, and then they rise very quickly, and they drop off in brightness in a very regular pattern. Okay, so why is this important? Well, at the time, there was a lot of talk about how big the universe was, right? And is Earth at the center? This picture on top here is the picture. It was drawn by William Herschel, basically of all the stars. He kind of tried to map out all the directions of all the stars he could see. And that's about what we knew about the universe at the time. So, of course, he has the Earth at the center because that's what he thought, right? So a lot of people in the question, a lot of people were asking, how big is the universe? Is the Earth at the center? And how do we find out? We could find the distances to nearby stars by using parallax. Now, what's parallax? This is just like if you hold your thumb out in front of your face and you close one eye and then close the other eye and you see it jump back and forth. The same thing works with nearby stars. And that's what this picture is here. Nearby stars that appear to move against the background star. So you can actually, with a little bit of math, figure out how far away they are. But that only works for things that are very close. How do you find out about things that are farther away? So the thing about Henrietta Leavitt is she actually studied all this. She has a brilliant insight. She actually figures out and draws out the relation that the brightness of the stars is directly related to how fast they change. So how fast that up and down cycle goes tells you exactly how bright that star is. So once you know that, the brightness drops off with distance. So when you know how bright that star should be based on the up and down, you can figure out how bright it actually is and how far away it is. And these Cepheids are, some of them are 100,000 times brighter than the sun. So they're very super bright. So the beauty is you can find out how far away things are that are really far away, right? You can actually calculate it. This lets one of the most famous astronomers, Harlow Shapley, or Shapley rather, I've got it spelled wrong, at Mount Wilson to reshape how we see the galaxy by mapping out distance to some objects called globular clusters. He was able to figure out that we're like sort of the edge of our galaxy. We're not in the center. It also was the key work that allowed Edwin Hubble to determine the distance to remote objects like the Andromeda Galaxy. You can see one of the pictures down here from Hubble where he's got a variable star marked. He built all his stuff on Henrietta Leavitt's work. And this starts Hubble on the path to changing cosmology forever and becoming a household name. It's not a storybook ending, though. It's a great accomplishment. She never really received any formal recognition in her lifetime for this foundational work. She dies of stomach cancer at the age of 53 in 1921. A postscript is the Swedish Academy of Sciences actually writes in 1925 to the director to nominate her as a candidate for a Nobel Prize. That's how big a deal this really was. Of course, you can't get a Nobel Prize posthumously. So, Edwin Hubble was often heard to say she deserved the Nobel Prize, and he very often said that. We'll also move to once Pickering retired, there was another director, Harlow Shapley. He's a bit of a card, but yet a tremendous advocate for women's rights. And it's odd because he and Pickering get a lot of static or a lot of blame, and there's a lot of sources on the internet that say the Harvard computers resented both Shapley and Pickering, but yet when you go to the primary sources, you don't see that at all. He was a journalist And when he went to college, the School of Journalism wasn't open yet for another year. So he went alphabetically down the list of majors. Archaeology was first. He couldn't pronounce it, so he picked astronomy. That's how he got into astronomy and becomes one of the most famous astronomers. He was director of the Harvard College Observatory for almost 30 years. He's a total character. He had all these great. He would fight. He would go against the House Un-American Activities Committee, the Red Scare paranoia, and fight that. But at the same time, he also felt strongly that any primate showing signs of intellect should be killed. So he's a real character. He was actually nicknamed the Dear Director by the Harvard computers. He started a graduate program for women in astronomy before they had a graduate program for men in astronomy. He offered a lot of fellowships to them, and he actually put their names on the bulletin that published the results. Pickering had put their names in it, but he actually had them sign it, and that was actually kind of a big deal. He was also very, very much an ally. He created a very non-hostile work environment because he allowed computers to choose their own research, and it was always very positive. Like, he'd say things like, "I think I can do this, so I know you can," and he was very much a proponent of women in astronomy. So I'll move on. My last one here is Cecilia Payne-Gaposchkin. She was British born. She read for astronomy and chemistry at Cambridge, but she saw a lecture by Arthur Eddington about the 1919 eclipse, and she said it was like a thunderclap, and she couldn't sleep for days. Decides to focus on astronomy and completed her studies at Cambridge, but the problem is they didn't grant women degrees until 1948. And this is just 1923. So there's no career options in the UK. So she comes to Radcliffe and gets a fellowship from Shapley, and he pushes her to get her doctorate. And she becomes the first to earn the PhD from Radcliffe in 1925. Her thesis is Stellar Atmospheres, a contribution to the observational study of high temperature and reversing layers of stars. Oh, that's really something, huh? So, okay, what, huh? So basically what she did is she took this work from an Indian astrophysicist, which showed that spectral lines, what spectral lines should be seen at high temperatures in stars based on ionization theory. And she basically showed why these stars relate directly to temperature, basically what's going on inside the stars. Because she had been at Cambridge and she was really familiar with the latest atomic theory, she was able to relate all this and she'd actually taking classes from Niels Bohr, who was the father of quantum mechanics. She had all this background. She was actually able to put it all together and explain why these classes of stars relate directly to temperatures, how temperature is the driver, what's going on inside the stars, all the complex physics. In addition, she took that and she went to figure out the amounts of the elements in the stars. And this is a big deal because everybody wanted to know or get measurements of this. And she concluded that the sun had the same relative amounts of carbon, oxygen, silicon, et cetera, as on Earth. In terms of if you look at the percentage of carbon versus the percentage of oxygen, or how much, it's the same relative amount, right, as on Earth. But everybody all believed at the time that the Earth and the sun were made up of the exact same composition. But she also kind of concluded the sun was mostly hydrogen, like there was 1 million times more hydrogen than there is here on Earth. And one of the famous astronomers at the time in Princeton was Henry Norris Russell, convinced her these results were spurious. I spelled it wrong, based on the belief that the Earth and the sun are the same composition. She also thought it wasn't true either. She said that it was a mistake, right? This is called the most brilliant PhD thesis in all of astronomy. Henry Norris Russell also derived the composition of the sun independently, got the same results, still didn't believe it because, that old idea. Otto Struve, who was a West Coast astronomer, actually got credit for the discovery. And this is really strange because he published a paper that also measured it and said, yes, this is true. But he actually directly credits Payne-Gaposchkin in his paper, but it never seemed to get through to anybody. The title of this slide, the most brilliant PhD thesis ever written, is a quote he often made, right? But still, even with all that, it took from 1938 until Shapley managed to get her an appointment to be an astronomer. She taught at Harvard, but her classes were not recorded in the catalog until 1945. In fact, George Lowell, when he was president of Harvard, he said when Shapley tried to get her promoted, he said as long as he was there, she would never, ever be promoted. Basically, she didn't get to be a professor until 1956, overcoming that. She later became the chair of the astronomy department. She was the first female chair at Harvard. So I'll wrap up by saying, how about today? Well, so we have a lot of these challenges and all these women made significant contributions. Well, certainly women still make significant contributions. Today, women account for about 25% of astronomy-related doctorates, but only 5% of the top positions are held by women. So there's still some challenges. When you look at all the statistics, you see a lot of statistics about this. It can be misleading. For example, women land academic jobs on average a year sooner than men. And they actually hire a lot more women than men. But why is that? Turns out women leave astronomy at a much higher rate. And so it appears there's still multiple challenges. I've got Me Too being one of them, are still present. I'm not an expert on all the challenges. In fact, there's a lot of professional groups working to understand and address issues. For example, the AAS inaugurated a committee on the status of women on astronomy to try to understand some of these issues. So that's really, I know, right to my 45 minutes. That really kind of touches on some of the women in astronomy, but there actually there's a ton of others, like Hidden Figures everybody knows about because of the movie, but JPL had computers, and there were a whole bunch of other women that actually contributed. This is just really a fraction of it, but hopefully it give you a little bit of an idea about some of the contributions that were made. I don't know, are there any questions? I'm sorry, I can't see the chat window.
So well, I just wanted to say thank you so much. This is such an important topic, and I think it really goes to show what the world, what today, we have a lot of problems, right? But it goes to show that we have come some ways, right? To, because just like, I'm analyzing the way I'm feeling as you're talking about these things, and just the utter unfairness, right, of the way these women were treated in their careers. And, and it makes you feel like really proud that there were some men that did recognize their brilliance and did try to move their careers forward. But then you have those people in power who prevented that. So
yeah, one of the things. I'm sorry. Go ahead.
No, go ahead.
I find most interesting is Cecilia Payne-Kapushkin had made a really good comment about that. She initially started out saying she said she didn't want to be treated different. But it turned out in not too much time, she kind of changed that. And she started saying, well, she said, men and women are different, which is fine. But she said, that's not the issue. It's not that it's okay to be different. But she said, I don't want to be treated inferior. And so I think she really understood it, right? That it wasn't about that things were different. It's about being treated as inferior or lesser. And that's I thought she really just put her finger right on it.
Well, I think to me, it's so interesting because as science aficionados, right, we want the best science and the most brilliant people working, right, regardless of who they are. I feel like it advanced, I guess our position is that we want science to be advanced the best way it can be. And to think that these people shared such a different view, like they would rather not have the discoveries and because of who was making them. It's so interesting.
Yeah, it's really fascinating. Once I started looking into it, like I started a number of years ago, just because it was interesting, I was actually quite surprised. And again, I have a background in astronomy. I was actually quite surprised about some of the significant contributions, that just I had previously been unaware of, right? I mean, I was aware of the science, but just, how we got there. So I thought that's fascinating.
Well, absolutely. And I think that these stories make it so, makes the discovery so much more interesting when you hear the stories behind them. And I really appreciate that you are telling these stories, that folks don't know. And it's really important to know that lots of different people have made these important contributions to science and discovery and where we are now.
Yeah, to me, it's absolutely fascinating. And again, I'm often surprised at how little information is really out there. So there is actually a really good resource on this for women, for learning about women's contributions to astronomy, put together by Andrew Fracknoy. So I don't know if there's if you have some place where we can post resources, but I can certainly send that
I
over.
think maybe Skelly, who's our moderator, can drop that link in the chat.
So for people that are wanting to learn more, it's a great resource for some of the names and some of the places you can find more information if you're interested.
Absolutely. Well, if I'm going to give folks just about another minute if they have any questions in the chat. But Ian, thank you so much. What a wonderful program. I'm so glad that we got to include it in our Astronomy Days lineup this year. And we do have some women astronomers are going to be presenting. Rachel presented this morning, Rachel Smith. Dr. Rachel Smith is one of our astronomers at the museum who works with Ian. Her presentation on open space is on YouTube already. And then we have a few more. We actually have one of the scientists working on James Webb Space Telescope is going to be speaking later this week, as well as some other folks. So please, in particular, check those presentations out. And so we do have a question from Jed about what would the Earth look like from the moon? Ian, any ideas?
What would the Earth look like from the moon? Well, so certainly would look like the Earth, but the interesting thing is it goes through phases, just like if you're on the moon, the Earth would go through phases just like the moon does, except it would be the opposite phase that you're on. So if you were on the first quarter moon, if the moon was in the first quarter phase and you were standing on the first quarter moon, and it would actually be the Earth would actually be in third quarter phase. So you would actually see it. That's why sometimes you don't see too many pictures of the entire round Earth coming back from like the Apollo missions or something, because you have to catch it just at the right time.
Very cool. Thank you for answering that. And you can Google some of those Apollo pictures that were taken from the moon. And in particular, there's the one that was taken out of the window that is so affecting
the Earthrise. Yeah, that's pretty amazing.
Yeah.
One of the things that's interesting about that picture is it was not planned, and right. You have to be in the right position to do that. You won't actually see that from the surface of the moon. You actually have to be in orbit. It was one of those chance things. Now they've had several satellites that put in intentional orbits to get that picture, but it was just a chance thing. It wasn't planned, and they ran it. And as someone who was alive when that was coming out, and at the time, most pictures in the newspaper, especially if you didn't live in a bigger town, were in black and white. It's one thing they ran in color. And it's actually credited with starting the modern environmental movement, because it kind of blew everybody away. And they started looking and say, hey, that's it. That's our whole planet, right? And you know, it's turned out to be it's actually, if I turn in my office here, it's one of the pictures I have mounted on the wall.
Yes, I just posted the link in the chat, so folks want to see what we're talking about. It is a very powerful picture. And I just wanted to make one more comment, Ian. Peggy says, thank you, that it was wonderful to have this brought to our attention. And as a woman who joined the workforce in the 60s, the difficulties were and still are there, but they're much better today. So yeah, I'm so glad that, thank you for sharing that.
You're welcome.
And I just wanted to thank you so much, Ian. It's so wonderful to see you. Ian moved away a few years ago, so I don't often get to see him. And I wanted to thank our sponsors today, North Carolina Space Grant and Pepsi. And then I also wanted to thank our museum members. So if you are a member, thank you so much. If you're not a member, please consider joining the museum. Your membership helps us put on events like Astronomy Days, and many other things. So we will have another program today at 5, Design a Planet. It's going to be a very fun activity. So bring your markers and paper and log in then, and I will see you there. And of course, we have got 6 more days of programs. This is our very first day of Astronomy Days. So thank you, everyone. I hope to see you at another program this week. And thank you again, Ian.
Well, you're welcome. Thank you, everyone, for attending.
Bye.
Bye.